right, well, let's look at 5.3, page 1. It wants us to write an equation for g of x in terms of f of x. So we're calling this graph f of x, and we're translating it to this graph that we're going to be calling g of x. And so we don't really need any values other than the A, B, C, and D values. So right here, this is what it's going to look like though. So I'm going to have still my blanks, except I'm going to have a G there now, right? So this is going to be A, B, C, and D. So basically I'm just comparing these two graphs. So here is this graph compared to this one right here. Okay, so here we can already notice that there was a reflection probably. Either, in this case, it was either over the x or the y-axis. Most commonly it is on the x-axis, so we're going to put a negative out in front. Okay, and then the only other thing I look at is the point of symmetry. So the point of symmetry was here at 0, 0. Now the point of symmetry is here at 0, 2. So really my graph just shifted up 2. So I leave the B blank, I leave the C blank, and I shift it up 2 with the D value. Okay, so to clean this up a little bit, again, my equation should be g of x is equal to negative, and I messed up. This should be an f. So this is going to be an f because it wanted in terms of f of x. So g of x is equal to negative f of x plus 2. So that would be in terms of f of x. Okay, so then again, if we try that with problem number 2, here is my graph for f of x. I'm transforming it to this graph, which we're calling g of x. And again, we want this in terms of f of x. So again, I know I'm going to have an f in there with my x. Okay, and then I just have to fill in my values, A, B, C, or D. Again, I start with my point of symmetry. So this one was at negative 1, 0. Now this one is at 0, 3. So that means it went right 1. So right 1. And it also went up 3. And then there was no reflection, and there's still no stretch or compression. So all that I need to do is fill out the C and the D value. So this would be a minus 1 if it went to the right, and this would be plus 3 since it went up to the top. So g of x is equal to f of x minus 1 plus 3. Okay, and so that's how you write it in terms of f of x. So we're just transformations. Everything's the same, except now we're just writing it in in terms of f of x. All right, so moving on to number 3 and 4. It says the equation of the polynomial function p of x is given. The equation for that transformed function m of x in terms of p of x is also given. Describe the transformations performed on p of x that produced m of x. So here it gives us two different equations. Here is one equation. This is p of x, okay, and it was x cubed. And then here is my second equation, okay, and again, this is just function notation where it just put the p in there. So it said this function p was transformed by these 3 numbers. Okay, and so we just treat it the same. This 4 is at the very beginning of the function, so this is an a value. This is attached to my x, so it's a c value, and then this is the d value. And so a 4 for an a value tells us that we have a vertical stretch. A negative 3 is a c value, says we went right 3. And then a negative 5 as the d value says we went down 5. And so that's what it wants us to do, okay? And then in number 4, it wants us to write the equation of the cube root function that has been transformed from the parent function. It was vertically compressed by 3/4. Okay, so vertically compressed is the a value. Reflected across the x-axis is also the a value. Left 4 is c, down 3 is d. And so now the cube root function, okay, cube root function is just that, okay? And so we start with this because this is the parent function, and then a is going to be out here, b, c, and d. And so the a value reflected means it's negative. Vertically compressed of 3/4, we keep that the same. Move left 4, so we add 4. We can choose to use parentheses here, or we don't have to. So if you did want to write the parentheses, it's fine as long as the 4 is underneath the root or the radical. And then down 3, make sure that the d value is outside the radical now. And so here is my equation.